Hello everyone, welcome to the NN Classroom. Today I'd like to share with you a past paper question extracted from 2018 again, time zone 0 in November, right? So let's see. Asking topic with the understanding in topic 20, organic chemistry in the higher level syllabus. Let's see. How many chiral carbon atoms are present in one molecule of this entire thing? So obviously, what you're going to do is find out as much as possible the chiral centers, this time only referring to carbons, right? So students should have realized that what is meant by a chiral center relate to the theory about enantiomers deduction, right? Is that chiral center, the simplest understanding, which means the carbon has linked to 4 different groups. What groups are they doesn't really matter, but what matters is that it must be bonded to 4 different things. It must be 4 different, not 3, not 2, but 4. So it must be a saturated situation and then bond to 4 adjacent different things. If we discover it, normally we mark a star on this carbon, indicating it is going to be a chiral center. With one chiral center, supposedly we can construct a pairs of enantiomers, right? So in this case, obviously, what are we going to do is try to draw the gamma out if you cannot spot it so easily by looking at this what we call condensed formula. So make it back to the structural formula. So first of all, we see CH3 for 2. 2 CH3 doesn't really make sense because normally the ending of a compound is only 1 CH3. But if you think of it, 2 of these CH3 both can be now bonded to the same carbon. So that's what I can see. With the carbon that's starting with this, I can now sketch in this way, CH3 and CH3, right? So now it's possible to have 2 CH3 now linked to the same carbon and then linked to continuously the hydrogen adjacent, right? Then next will be another carbon, right? So this is normally the way of how I read the condensed formula. And I know quite a lot of the students don't know how to read condensed formula, right? So let's see. So this will be double CH3 bonded to the C, linked to the H, continues with a C, and then H, and then Cl. So which means one side is H, one side which is a Cl, right? So that's why the way for me to read it is kind of easy. Just scan through it from left to the right, one by one, and predict the bonding pattern, not violating that carbon must be only having 4 bonds in total, right? Makes sense? And so after chlorine will be the next carbon that bonds to H and then Br. So that's a one side is H, one side that must be a Br, and finally to a CH3, so terminal, right? So this is the sketching of the full structural formula. So no doubt what you can spot it out is that all the carbons are being located, and the only carbons that have bonded to 4 different groups are only this one, as you can see, one with the H, one with the C, something else, one with the C but another thing else, and a Cl, right? And also this carbon, right? Bonds to CH3, hydrogen, C with a bunch of things, and then bromine. So that's why finally only 2 carbons are chiral. But if you look at this carbon, both groups are CH3, the same thing, right? So that is not going to be chiral. And then the surrounding carbon in the CH3 obviously not, because one carbon now bonds to at least 3 of the same thing, hydrogens. So that's why obviously only 2 chiral centers we can observe. And so finally the answer C